Okay, so let's look at our important ideas. Basically, we know from the first simulation that certain um, points will affect the line and the slope and the y-intercept and all the things a little more than other points will. And so the outliers, the boundary lines we used essentially were the mean of the x values and the mean of the y values, and these are the symbols for that. So x with a bar on top, I'll just kind of write an example here. X bar is the average of the x values. So that's some new notation. It's a little average of the x values. Then what we want to do to tell if we're going to use these as boundary lines, to tell like where our line is tilting or shifting, if we like add points in places, it kind of allows us to decide, are we tilting it, are we shifting it when we're doing things. So how do we know if we have a good least squares regression line? Generally, we want it to fit the pattern. So we hope there aren't points that are crazy out there. That like affect the pattern, but the two values we can check are these two. So when we're looking at data and we're looking at points in the data, we're hoping there's no outliers that are affecting these two measurements, so S and R squared. So remember, S is like your average amount of error, like how far off you are every time. So we want that to be pretty low. We're hoping our line is close enough to our point, so our predictions are pretty on point. And then the R squared is basically like we want that to be high because that's how much of the variability is accounted for by the line. So basically the amount of wiggle space, the wiggle room we have, and how much of that we consider to be okay percentage wise. So we want that one to be high because if we have that being a high value, it will ensure that most of our data and variation in the data is accounted for. And then if the S is low, that means every time we make a prediction, we're pretty on par with where we should be. So this crazy stuff, which is a little new here, this is technically, you can use S and R and different things to actually write the equation of a line instead of using the computer. So these formulas would be given to you on the AP exam. This question has come up once in a blue moon, so that's why I don't spend tons of time on it, because historically this has not really come up. Technically it could, so that's why I kind of go over it. But basically, in the check for understanding, you're going to use these formulas and the values that are given to plug and chug and come up with the y-intercept and come up with the slope number. So there's a video of me going through that on the check for understanding if you'd rather just watch that to make sure you're good on it instead of struggling through and trying it first with all the crazy symbols here. That's fine with me. It's usually when we go through together every year.